Welcome back, students. So now let us learn the program number 7, the lab program number 7, Dijkstra's algorithm for a given graph to find the single source shortest path using Dijkstra's algorithm. So first, let me start with the main function execution. The program I have divided in the parts how the flow is going to happen, the program execution flow. Okay, so first every program execution start from main function as we know. Okay, so here I have written the program completely step by step how the flow will happen. So later I will send the program, you can compile and you can see. Okay, so first let me start with the main function. So I and j, two variables I have declared. This is used in the looping iteration purpose because graph is accepted in the form of an adjacency matrix that we have discussed already in the Prim's algorithm also. So integer distance, this is an array. As we know in our algorithm also we were having this array. Okay, so this array is used to record the distance from one vertex to another vertex, means nothing but from source vertex to destination vertex, whatever may be the remaining vertices, all other remaining vertices are destination vertex. So from the source node to reach all the remaining nodes, what is the distance? That information you are going to store it in this particular array. Next step is integer visited. So integer visited is nothing but this is used to record whether that particular node is already visited or not visited. Once you have considered that particular node or a vertex, so next time you should never consider that as a remaining vertices. That's the reason we will making use of integer visited, this array. Then path. So as we know, our algorithm need to print the output as in which particular path you have traversed to reach the remaining vertices from the source vertex. That to record that information, I am making use of the word array called as path. This array is used to record that information. The next we are having two-dimensional array integer cost. Okay, this is used to store the adjacency matrix. What is adjacency matrix? The given input graph is converted in the form of the input of the edges is considered in the form of an edges. So that information you are going to record, the edge weight you are going to record in the form of a matrix. To read that input, we are making use of this two-dimensional array. So for a scanner class, we are creating the object called as in. This is required to read the keyboard inputs. So first and foremost thing, you are going to specify system.out.println, enter the number of nodes. So this is our first output statement on the output screen once you start executing your program. So this is used to record, means this message to the user stating that before that your graph should be ready. So you should plot one graph. It can be directed graph, it can be undirected graph. Their corresponding cost adjacency information you should have. Okay, then you will specify how many number of nodes are present in your input graph, which graph you want to give it as an input. So that information will be recorded in the variable n. Next, system.out.println, enter the cost matrix. So your cost matrix will be ready. So that cost matrix will be run. This loop, these two loops will run and will be recorded in the cost of ij is equal to in dot next end. Since we are storing everything as an integer type variable, so we are making use of it. So if you run this, suppose I have considered an input graph like this. Okay, let us see. This is my input graph. In this graph, it consists of totally 5 vertex. So number of vertex is equal to 5. So for this particular statement, enter the number of nodes. My input is 5. N is equal to 5. Next, enter the cost adjacency matrix. This is my input for this particular statement. Okay, 0, 4 space 999. Why space 4 means? So from the 1 to 2, we have a edge 4. But 1 to 3 I don't have a direct edge. So whenever you don't have any edges, directed edges, so you, instead of making use of infinity, because infinity we will understand when we are solving the problem, it indicates that there is no edge, directed edge. Okay, but when you are giving an input to the computer, so you should fix up some value. That value you are assuming it as infinity value. We don't know what is that value that we need to compute. That's the reason I am making use of 999 in the place of infinity when there is no direct edge. But 1 to 4 there is a edge with the cost 8. Similarly 1 to 5 there is no directed edge. That's the reason I have mentioned it here as 999. Similarly you need to follow from other vertex also. 2 to 1 it is 4. 2 to 2 there is no self loop 0. So 2 to 3 I have a edge 3. But 2 to 4 I don't have a edge 999. Similarly 2 to 5 also I don't have an edge 999. So this is how you need to prepare the cost adjacency matrix and that you need to give it as an input. Once after reading the input graph, what is our next input? Our Dijkstra's algorithm accepts two input. One is cost adjacency matrix. The second one is source vertex. What is the source vertex? That is there in the next statement. System.out.println, enter the source vertex. So read the source vertex. So source vertex information is available in the variable called as SV. So SV stands for source vertex. That in short I have written as SV. Okay, integer SV is equal to in dot next in. So read the input. Here in this particular graph I have assumed the vertex 1 as input source vertex. Okay, input source vertex I have assumed here for my solution. Okay, you can assume any other vertex as a source vertex, that is that there is no difference, but only you will get a different path, that's it. But tree you are going to get it in the same fashion. Okay, so then once after reading the source vertex, now it's the time for you people to call the Dijkstra's function. I have written one function called as Dijkstra's. Dijkstra's function accepts the argument as cost adjacency matrix, then distance, a empty array, then SV source vertex, then n is equal to 5 as per this particular graph, then path, an empty array, then visited, an empty array. So this method is going to get called. So once after the computation, so you will come back to this particular statement. The next statement is print path. Okay, once after computing the distance between from the 1 to reach 2, 3, 4, 5. Okay, then you will be printing the path. So finally your output should be printing the path. So from 1 to 2 you have it directed. To reach 1 to 3, either you need to traverse from 1 to 2, then 2 to 3. Okay, that path information you are going to print it. So with the help of this particular method. Okay, so let us see how our Dijkstra's function will work. First, let us start with this. Okay, so Dijkstra's function is going to commence in this fashion. It consists of 6 arguments. So cost array, distance array, source vertex, number of vertices, path, and visited. Okay, so then here you have 6 arguments. Integer count is equal to 2. So this is the variable which is responsible for our anchor condition, because totally 5 vertices are there. We need to compute from the second vertex, because first already we have considered one vertex as a source vertex. So remaining vertices we need to find the distance. That's the reason I am initializing count is equal to 2. Once after visiting all the vertices, my algorithm should stop its execution. That's the reason I am starting from count is equal to 2. Then minimum, this is a variable required to find out the minimum edge. V is equal to 0. This is responsible to record which is the next vertex I have visited. Okay, for I is equal to 1 to n, I plus plus, initially you need to record an information stating that whether you have visited that particular vertex, what is the initial distance from the source vertex, what is the initial path, that you need to record it. This is most important. This is the important step. If you write this step properly, then you can able to proceed further for the algorithm execution. Okay, if you execute the above instruction, first initially I is equal to 1, I less than or equal to 5. So condition is true. Visited of I nothing but visited of 1. Since the value of I is equal to 1, visited of 1 is equal to 0. Directly we are initializing it to 0. Even though source vertex is also not visited initially. So our algorithm still not yet started executing. Then distance of 1. Distance of I value is 1. Distance of 1 is equal to cost of source vertex comma I. Means from the source vertex to the actual vertex, what is the cost? Cost of 1 to 1 is 0. So if the cost of 1 to 1 double equal to 999. No, it is 0 double equal to 999. Condition is false. So if the condition is false, we will go for else, and path is equal to source vertex. What it indicates? From the source vertex, you have a directed edge to reach that particular vertex. Path is equal to 1. So here path is 1 for 1. Path is 1 only because there is no parent node. Similarly, I is equal to 2. I gets incremented. I is equal to 2. 2 is less than or equal to 5. Condition is true. Visited of 2 is equal to 0. Yes, it is done. Visited of I is equal to 0. I value is 2. 2 is equal to 0. Then distance of I. Distance of 2 is equal to cost of source vertex. Source vertex is 1. Then I value is 2. So cost of 1 comma 2 is equal to 4. You can look up the adjacency matrix. What is the cost? Cost of 1 to 2 is equal to 4. So 4 you have written here. If of cost of 1 to 2 double equal to 999. So it goes to the else part. This if condition will not get executed. This condition will lead to false. Path of I is equal to SV. Means path of 2 is equal to 1. It indicates that path is there already from the source vertex. To reach a node 2, there is a path. From the vertex 1 directly you can able to reach. This shows the path. Okay. Once you increment the value of I again, I is equal to 3. 3 less than or equal to 5. Visited of 3 is equal to 0. Then distance of 3 is equal to cost of 1 to 3 is equal to 999 because from the vertex 1 to 3 there is no direct path. That's why the value here is 999. If of cost of 1 to 3 is equal to 999, yes, condition is true. 999 is equal to 999 since there is no path. That's why path of I is equal to 0. If path of a particular vertex is equal to 0, it indicates that you are supposed to find the path of the particular vertex. To reach a particular vertex, since you don't have a direct path, you need to find the alternate path to reach it. Okay. I value gets incremented by 1 again. I will be equal to 4. The same step is going to get repeated. Visited of 4 is equal to 0. Distance of 4 is equal to cost of 1 to 4. Means nothing but source to particular vertex. 1 to 4 is equal to 8. Since we have a direct edge, so else part is going to get executed. Path of I is equal to 1. Means path of 4 is equal to 1. So it indicates that there is a direct path. Similarly, I is equal to 5. 5 less than or equal to 5. Sorry, here I should write less than or equal to less than or equal to. So less than or equal to 5. Visited of 5 double equal to 0. Condition is true. So distance of 5 is equal to cost of 1 to 5. It is already 999 because from 1 to 3 you don't have a directed path. That is why path of 5 also is equal to 0. Path of 5 is equal to 0. So it also need to be found. Once after basic evaluation is over, once after the basic evaluation of this particular steps is over, now it's the time for you to compute the vertex. So first basically what we are going to do, visited of SV is equal to 1. I have considered the source vertex initially. So source vertex is already visited. That's why count is initialized to 2. Initially only we have initialized count is equal to 2 to avoid the confusions, or else you can declare the variable and you can initialize after this step only. Not a problem. Okay. So visited of I is equal to 1. Okay. Once after this we will start our execution. I will continue that in the next video.